Welcome to the Deep Dive. Today we are focusing on, well, the most fundamental bedrock action in all of version control,
The git commit.
the git commit. And this isn't just about, typing git commit XEM and hoping for the best.
Right.
This deep dive is about deconstructing that one action, really understanding its anatomy, and turning it into a tool of, well, surgical precision.
And you really have to. If you're aiming for true mastery of version control, or maybe you're navigating a certification exam that requires a really granular understanding of Git, you absolutely have to understand the commitment you are making when you create that commit object.
It's everything, isn't it? If you imagine Git as this comprehensive time machine, the commit isn't just a record of a change.
No, not all.
It's the essential permanent snapshot that lets you instantly return to a specific fully functioning moment in history. It's the core unit of work that everything else,
Branches, merges, tag.
all of it all builds upon the commit.
That's the perfect way to frame it. So our mission today is to move entirely beyond just the command line. We're going to analyze the commit's actual data structure, like what Git stores in the repository.
Okay.
And then we'll move into the best practices for crafting truly effective commits. Understanding that duality, the technical structure, and the human communication, that's what's crucial for making Git history work for you.
All right, let's unpack this. Let's start with the underlying anatomy. When we type git commit, what is Git actually creating, technically speaking? I mean, we always hear it's not just a record of changes, but a complex object.
That's exactly right. When Git runs the commit command, it doesn't do what older systems did. It doesn't calculate and store the difference or the diff between the current state and the previous one.
Like Subversion used to.
Exactly like Subversion. Instead, Git creates a permanent, complex object that stores three very specific types of information. And these three things define its existence and its relationship to the project's history.
Okay, so tell us about those three key components.
So first and most critical, it stores a pointer to a tree object.
A tree object.
Yeah, and you can think of the tree object as like a notarized blueprint of your entire project directory at that specific instant. It has the complete list of files, folders, permissions, their contents.
So it's the full snapshot of the entire project state, not just a list of the files you happen to modify.
The entire state. And that distinction, the snapshot versus the diff, is huge. It's why Git operations feel so fast and why history traversal is so reliable.
Because every commit is self-aware.
Yeah.
It knows the state of the whole project instantly. You don't have to piece together history from 1,000 tiny changes.
Exactly. Git calculates the diff when you ask for it, but it stores the full picture. So the second component, which provides all the context, is pointers to its parent commits.
Right. This is how the history chain is built.
This is it. Every single commit, except for the very, very first one in the repository,
Exact.
what we call the root commit, has at least one parent pointer linking it directly back in time.
And that chain, that lineage established by the parent pointers, that's the digital thread holding the project together.
It is the absolute backbone. I mean, that linearity allows developers to traverse history quickly, to do precise file archaeology, roll back changes cleanly, or trace the specific origin of a bug to the exact line of code and the exact moment it was introduced.
Okay, so we have the snapshot and the parent link. What's the third piece of this anatomy?
The third piece is the necessary human and temporal context. It's the metadata.
Right.
And this context is vital because it explains the who and the when. It includes the precise timestamp of the action, and importantly, it tracks both the author and the committer.
I think that author versus committer distinction is often glossed over, but it's really interesting. They're often the same person, but when are they different?
Well, that distinction comes into play when you have collaborative workflows, where people are submitting patches or changes from outside the main repository process.
So like via email, or if you're cherry-picking a commit from someone else's branch.
Precisely. The author is the person who originally wrote the code, who did the intellectual work. The committer is the person who ultimately applied that change to the repository, thereby creating the commit object and setting the timestamp.
So the structure makes sure every record has the full state of the project, the snapshot, plus all the context for its place in history, including who wrote the code and who merged it in. It's really designed for robust traceability.
That's it. It's a self-contained unit of history, ready for inspection at any time.
Okay, so now that we understand what a commit object is, let's talk about the unique process of creating one. Because it's not like saving a document in Word. There's this intermediate step in Git that frequently confuses new users,
The two-step dance.
the famous two-step dance.
Yeah, and that dance revolves entirely around the staging area, which you'll also hear called the index. This intermediate zone is what separates Git from almost every other version control system out there.
And it's arguably Git's biggest superpower.
It is, but it requires the developer to be highly intentional.
So let's walk through those two distinct steps. How do you get your raw changes from your working directory into that permanent commit object?
So step one is staging, and you kick this off with the git add command.
Right.
As a developer, you're modifying files in your local working directory. You make changes, but those changes they're just local and temporary for now. Before you commit, you have to explicitly use git add to select which portions or which files you want to include in the next snapshot.
And that action moves those intended changes into the staging area.
Correct.
I like to think of the staging area as like a pre-flight checklist. It's where you gather all the pieces you want to launch together, making sure everything is accounted for before you push the final button.
That's a great analogy. The staging area is literally just a holding zone for changes that you've decided are logically complete and are ready to be recorded together.
And then comes the final step.
Step two is committing, which you do with git commit. When you run this command, Git looks only at the contents of the staging area.
Only the staging area.
It packages everything currently residing there, and nothing else, into a brand new permanent commit object, assigns it the current timestamp, and stores it in the repository history.
And this is where the power of the staging area really clicks for the learner. It allows for what you called surgical commits.
Right.
Let's say I've been working all morning. I've made 10 different changes across 2 files. 3 of those changes fix a critical security bug, but the other 7 are just, aesthetic fixes for the UI.
Okay, classic scenario. If you didn't have the staging area, you'd be faced to bundle all 10 of those diverse changes into one Franken commit.
Right.
And the commit message would have to be incredibly vague, something like updated CSS and fixed login error. That commit is messy, it's hard to review, and it's impossible to easily revert if you decide you hate the new CSS.
But because of staging, I can use git add to selectively pull only the 3 security bug fixes into the staging area.
Yeah.
And then run my first git commit. The other 7 changes, the aesthetic updates, they're safely left in my working directory, ready for a completely separate subsequent commit focused only on styling.
Precisely. And this enforces the essential rule of good version control. A commit must be atomic. It should encapsulate one logical change and do it well. The staging area is the tool that makes separating those concerns bug fix versus styling possible. It ensures a clean, logical history for everyone else reading the repository.
But wait, if the staging area gives us this power, isn't there a risk that people become too granular? That they create 10 tiny commits that are individually meaningless instead of one logical feature addition? Where's that balance?
That's a fair question, and it really speaks to the art of using Git well. The goal is logical atomicity, not necessarily minimal file size. So, if those 7 styling changes are all part of one refactor UI layout task, then they should definitely go together in one commit. If they're 5 distinct styling changes for 5 different components, maybe they do need 5 different commits. The key is, can a future reviewer understand the purpose of the snapshot just by looking at the commit message and its body?
That's a great litmus test. Purpose. Okay, so now we know how to build the object and what it contains.
Yeah.
But we need to move on to the final and most human element.
The message.
The message. Because for industry standards and for certification, simply recording history isn't enough. The documentation has to be world-class.
Absolutely. The commit message is mission-critical documentation. I mean, 6 months from now, if you're tracing the origin of a nasty regression, that message is your fastest, most reliable clue as to why a specific block of code exists.
A poor commit message is like that vague diary entry, I did stuff.
It's useless.
It's totally useless. A great message is essential documentation for future developers, providing that necessary context that the code itself just can't deliver.
And the industry standard, which is very widely adopted and reflected in exam criteria, dictates that a good commit message must be structured in 2 distinct parts.
And they have to be separated by crucial blank line.
That blank line is key.
So let's break down that standardized 2-part structure, starting with the headline that everybody sees.
That is the subject line. This has to be concise. A single line, ideally constrained to 50 characters or less. It must quickly and clearly summarize the change. And crucially, it must be written in the imperative mood.
The imperative mood rule is so interesting. It means writing it as a command, not a descriptive past tense statement.
Exactly. You write it as if it were a command or a functional description of the change it introduces. So instead of writing fixed a major bug, you write fix a major bug.
Not updating documentation, but update documentation.
Perfect.
So the idea is, if applied, this commit will do something.
Yep.
It makes the history read clearly as a series of actions taken on the project, so to make sure we've got it. Bad is changes to header. Good is refactor, simplify site header. Bad is merging in feature. Good is merge feature branch for user profiles.
That's it. That subject line is the quick answer to what changed. Now for the second and often neglected part.
The detailed body.
That's the body. This is where you use a detailed wrapped paragraph or even a list to explain the why.
Okay.
Why was this change necessary? What problem does it solve? What context is needed to understand the code? And did it introduce any potential side effects or known limitations? This body is where future developers will spend the most time.
I remember seeing one real-world commit message years ago that just said, small update. And that commit introduced a dependency injection change that broke half our integration tests.
Oh, no.
If the body had just said, this update shifts our main authentication library to handle asynchronous calls, it would have saved us days.
That's the pain point, isn't it? The body prevents that future forensic headache. So let's provide that final concrete contrast between a bad message that offers no value and a stellar one that serves as perfect documentation.
Give us the truly useless message first.
A terrible message, one we see all the time, would be something like, updated config and made changes to the main script.
Vague, tells you nothing about the what or the why.
Nothing.
And the good example, following the imperative mood, subject line limited to 50 characters, and that essential blank line separating it from the body.
The stellar message looks like this. Fix. Prevent null pointer exception on user session. That's the concise imperative subject. Then, a blank line, followed by the body.
And the body would say,
This change introduces a comprehensive null check during the user session initialization process. This resolves a reported critical bug, ticket 456, where users attempting to log in with expired tokens would trigger an application crash rather than redirecting to the relogin page.
that is infinitely more useful. You get the precise action, the context of the bug, the solution, and even a reference ticket, all without looking at a single line of code.
It's documentation that travels permanently with the code. It transforms the commit from just a file snapshot into a readable chapter in your project's history book.
And it proves that the power of surgical commits, enabled by the staging area, leads directly to the clarity needed for that clean subject line. It all feeds into creating a repository history that is readable, traceable, and reliable.
It all connects.
Okay, let's bring this deep dive into the Git commit to a close with a final summary checklist tailored for you, the listener, to make sure these concepts stick.
First, remember the anatomy of the commit. It is a permanent object. It's a self-aware snapshot pointing to the tree and establishing its position in history via pointers to its parents.
Second, remember the workflow. It requires that mandatory two-step process. You have to use git add to stage your changes surgically, and only then use git commit to save those staged changes permanently. Never merge unrelated work into a single commit.
And third, prioritize the message. Always write an effective commit message. Use an imperative subject line for the what and a detailed body for the why, separated by that crucial blank line for readability.
So what does truly mastering this one single action mean for the big picture of software development?
It means stability. If every single person on a team commits cleanly, using atomic changes and detailed messages, the project becomes exponentially easier to manage. Clean commits are the absolute foundation of healthy version control systems.
They're what allow complex projects to scale without just collapsing into unreadable, unmanageable chaos.
Exactly. Master the commit and you master collaboration.
A profound reminder that the smallest unit of work has the biggest impact on the project's long-term health.
That's it for this deep dive. Thanks for joining us.
We'll see you next time.